What are maybe some of the technologies you see being employed in the fluid power industry to aid with the digitalization of hydraulics, pneumatics, and of those technologies, what are some that either Moog is currently employing or maybe or looking at and or sees opportunities for use
Yeah,
of?
that's a good question. And first, from a high, kind of generally speaking, the first technologies that come to mind when I think of digitalization are that are fundamental to digitalization are uh, sensors and controllers.
Mhm.
However, sensors and controllers can only do so much uh, when with the physical hardware, such as valves, um, because this physical hardware is so critical to the performance, efficiency, and capability of the machines that these hydraulic systems are working on. So, for example, position sensors and a controller can certainly help with that control, but you can only go so far. And as Marcus spoke to earlier, um, you have to at some point have to start changing hardware if you want to make the control even better. So for example, you would need to change the control valve, the null cut on the control valve, or go to a different type of control valve um, to get even finer control. Well, Mo Construction helps the OEMs create the next generation machines that allows for the machine to really be infinitely tunable because it's digitalized. You can tune the control and the feel of the machine without having to change hardware. You're able to flash that over the air updates through software without having to modify that hardware. So, we have developed and manufactured several technologies here at Moog. Um, Core digitalization technology at Moog Construction is our ruggedized electronic solution, which consists of control, power management, thermal management, and tunable software that completely integrate with the machine. But then you take that controller and that um, and the um, and the sensors, and you now integrate them with other products that Moog also can provide, which are like electric motors and electromechanical actuators. Now, at this point, you have a full system um, that can communicate with each other, the
Mhm.
sensors, the controller, and you can do over-the-air updates without having to change hardware of the system.
Nate, as you were talking, I was thinking back to the conversation we had before this recording started about electromechanical and the journey that we've been on through those technologies. And I was reminded that electromechanical has somewhat of an advantage at the moment with respect to digitalization because, like Nate said, you have to have electrical sensors, electrical controllers. You've got to be able to measure things within a product in order to be able to make it digital. You've got to know what is happening because just as Nate described, we've got to be able to make products more effective, more efficient, more intelligent. And to do that, the systems have to be able to make decisions. And to make decisions, they have to have knowledge. And to have knowledge, you've got to be able to measure things. And I think hydraulics is in a really interesting place at the moment where it needs to take a bit of a leap forward in order to catch up with that inherent advantage that electromechanical has, because it has electrics on it by definition, And so where we see the technology being pulled to start off with is sometimes just in the most simple form in hydraulics, that is putting electronics inside the hydraulic components. So rather than having a really simple mechanical hydraulic component, and then that being controlled from central electrical control system, we're seeing a real pull towards putting electronics onto the product, where you're directly sensing, directly measuring, and controlling within the product. And we see that within some of our within our direct drive servo valves, that are a big pull from customers is to increase the level of intelligence in their systems by having electronics on board of the valves. And that's a really big pull for us. The other thing that we've discovered over the journey is, again, exactly as Nate described, often the limiting factor in hydraulics is not the ability to write software, it's not the ability to control things, it's the hardware.
Mm.
And one of the really great things for us is when we designed the products that we have, we already were in the world of digitalization. So the hardware has been designed with software and digital control and digital configurability in mind.
And Frank, from your perspective on the pneumatic side, what are some of the technologies you guys are seeing being employed or evaluating?
So it's interesting because it's interesting taking the perspectives from 3 different companies and doing in different technology areas, doing things slightly differently, but coming back to the same basics of digitalization. So our emphasis has really been on software development, where we build data models to replicate pneumatic functionality. And this becomes very important in understanding how a pneumatic system, a pneumatic device works, so that you could start to think about how to predict its behavior going forward. So software is a key piece here. But also was mentioned hardware and hardware limitations. We've seen hardware limitations, for instance, with the pneumatic valve, how typically pneumatic valves have been actuated for, I won't say millions of years, but many years with solenoids. And they have their limitations, how a solenoid works and so on. And so what we've been doing is using piezoelectrics as the valve actuation and applying software to that piezoelectric actuator has opened up really a whole other world of how to, I love the term that Marcus used, change the personality of that valve